Okay, let's just jump right in. Chemical injuries. I know it sounds like something straight out of an industrial factory nightmare, right? But honestly, this is a hidden threat that could literally be sitting right under your kitchen sink. Today, in this explainer, we're going to demystify the terrifying yet absolutely fascinating science of chemical burns. We'll break down exactly how these compounds interact with the human body, and way more importantly, how you can actually stop them. We're going to follow a pretty clear roadmap today. First, the hidden chemical threat. 2, how chemicals damage tissue. 3, immediate treatment and triage. 4, the chemical rogues gallery. And finally, 5, special chemical hazards. All right, kicking things off with section 1, the hidden chemical threat. Just think about this number for a second. There are currently over 500,000 different chemicals in use today. And out of those, more than 30,000 are formally classified as hazardous by regulatory agencies. We are interacting with a massive, mind-boggling catalog of volatile substances every single day without even realizing it. And the sheer human toll here is staggering. Roughly 60,000 people seek medical care for chemical burns annually in the U.S. alone. They make up about 3 to 4% of all burn center admissions. So what you really need to take away from this is that these injuries are incredibly common. But here is the truly insidious part. Chemical burns are deceptively superficial at first. They're progressive. What looks like a mild, harmless rash could actually be the beginning of some serious deep tissue destruction. Moving right along to section 2, how chemicals damage tissue. So what actually determines how bad a chemical burn gets? Well, the severity isn't just about what the chemical is, its composition. It's heavily dependent on a few other things: the concentration, the temperature, the sheer volume you're exposed to, and the duration of contact. Basically, how much of it is there, how hot is it, and how long does it sit on your skin before you can wash it off? Those 5 factors dictate the ultimate depth of the trauma. Now, this is where public perception gets it totally wrong. Everyone thinks acids are the absolute worst things you can spill on yourself. But the reality? Alkalis, which are bases with a pH above 7, like your everyday drain cleaner, are usually much worse. They cause what is called liquefactive necrosis. They quite literally melt your tissue and fats into soap, which allows the chemical to just keep spreading deeper and deeper into the body. Acids, on the flip side, cause coagulation necrosis. They essentially cook the tissue into a thick, leathery scab that actually acts as a barrier and limits the spread of the injury. So yeah, an alkali burn is usually way more insidious than an acid burn. And we absolutely can't forget our third category, organic compounds. These are solvents, like petroleum products. They damage tissue by literally melting the fat right out of your cell membranes. But worse than that, once they absorb through the skin, they get right into your bloodstream and just wreak havoc on your internal organs, frequently leading to severe systemic failure in the kidneys and liver. Okay, let's jump to section 3, immediate treatment and triage. If there is one thing you remember from this whole explainer, let it be this life-saving protocol. First, rescuers have got to put on PPE, contaminated clothing, off-gases, toxic fumes, and you do not want to become the second patient. Second, and listen closely here, brush off all dry powder chemicals before adding water. Then, remove contaminated clothing, and finally, begin massive, continuous water irrigation. Seriously, if you skip step 2 and just dump water onto a dry chemical powder, you might trigger a horrific heat reaction. Which brings us to the absolute golden rule of chemical burns. Efforts to neutralize the chemical are contraindicated. I cannot stress this enough. Do not play high school chemistry here. Never try to neutralize an acid with a base or vice versa. If you do, it creates an exothermic reaction. You will literally cause a thermal explosion right on the patient's skin, compounding the chemical burn with a massive heat burn. Just stick to water. Though, as we're going to see in a minute, there is one terrifying exception to this rule. Now, before we move on, we've got to talk about eyes. They are incredibly vulnerable, especially to those blinding alkali burns we talked about. To save a patient's vision, hospitals use a clever little device called a Morgan lens. It's essentially an irrigating catheter fitted directly over the eyeball, and it allows for prolonged, continuous flushing with saline to wash the chemical right out of those delicate eye tissues. All right, section 4, the chemical rogues gallery. Let's look at some specific culprits. First up is a real wild card you might not expect: cement. Dry cement powder looks totally harmless at a construction site, but it contains calcium oxide. Once a worker's sweat activates that powder, it transforms into calcium hydroxide, which hits a highly caustic pH of 12. It literally melts through the skin over a 6 to 12-hour shift, all while the worker just assumes their boots are rubbing them the wrong way. Crazy, right? Next up, anhydrous ammonia. This is commonly used in farming fertilizers and, unfortunately, illicit meth labs. This one is uniquely terrifying. It's a strong base activated by body moisture, but it's stored as a pressurized liquid. So if you're exposed, it rapidly evaporates, literally freezing your skin and causing severe frostbite at the exact same time it's chemically burning you. Add in permanent blindness if it hits your eyes, and delayed respiratory edema that can collapse your airway hours later. Yeah, it's bad news. Then there's hydrofluoric acid, or HF. You might actually have this in your garage right now in heavy-duty rust removers. HF acts like a biological assassin. While it's technically classed as a weak acid, the fluoride ion penetrates deep into your tissue and rapidly binds to the free calcium and magnesium in your blood. It sucks the calcium right out of your system, triggering fatal cardiac dysrhythmias. Essentially, your heart just stops. Now, remember a few minutes ago when I said never neutralize a burn? Well, hydrofluoric acid is the one rare, terrifying exception. For HF burns, first responders must immediately apply a topical calcium gluconate gel. You basically have to feed the chemical the calcium in the gel so it eats that instead of the calcium inside the patient's body. Next on the list is phenol, an acidic alcohol used in heavy disinfectants. Phenols are tricky. Paradoxically, dilute versions of it actually penetrate the skin faster than concentrated ones, because the concentrated ones form a thick scab that blocks further entry. And since phenol isn't very soluble in water alone, treating it requires copious water flushing, followed by thoroughly cleansing the skin with 50% PEG or ethyl alcohol just to dissolve and remove the chemical completely. Rounding out our gallery, we have petroleum products, like gasoline and diesel. If someone is trapped in a car crash with leaking fuel, fire isn't their only risk. Prolonged contact causes delimidation, literally melting the fat out of the skin. It causes full-thickness burns that look deceptively superficial. And because these hydrocarbons absorb so fast, they can shut down the lungs, liver, and kidneys in under 24 hours. Getting those soaked clothes off immediately is absolutely critical. Bringing us to our final part, Section 5, Special Chemical Hazards. First up here, chemical warfare agents. Obviously, we hope to never encounter them, but agents like mustard gas and lewisite are called vesicants. They are specifically engineered to cause severe skin blistering and massive multi-organ toxicity. But the treatment protocol actually relies on the exact same core principles we've discussed today: rapid isolation, high-level PPE for the providers, massive water decontamination, and immediate airway management. And finally, a very real, incredibly volatile hazard first responders face all the time: clandestine meth labs. These environments are saturated with totally unstable chemicals like red phosphorus and ether. There's a massive risk of explosions, meaning patients usually present with a devastating mix of thermal fire burns and chemical burns at the same time. On top of that, the patients themselves are often highly combative, dealing with severe tachycardia, agitation, and paranoia from the drugs, which makes safety contamination an absolute nightmare for medical teams. So, what does this all mean for you and me? Well, knowing how fast alkalis melt tissue, how organic solvents shut down your organs, and how incredibly specific some of these treatments have to be, ask yourself, how many hazards are sitting under your sink right now? Drain cleaners, rust removers, solvents? Are you truly prepared to safely handle an accident if it happens? It is definitely a sobering thought, but understanding the science is the absolute best first step to staying safe. Thanks for joining me on this explainer. Keep learning, stay curious, and for sure, stay safe out there.